Welcome to Chatter. I'm David Priess, publisher of Lawfare. This week, science journalist Fraser Cain on the moon, Mars, and national security.
I mean, no one will really just say, this is a race, we're in a race. If we can get there first, then we're the best. If you can set foot on Mars, it makes absolutely no difference to you as a nation. Like, you did it. You are able to send humans to space. Congratulations. It was incredibly expensive. Hopefully nobody died. It is a point of pride. If at some point we're seeing helium-3 mines on the moon and it's powering Earth's fusion reactors, then we've seen how resource wars play out. But for now, there's no money to be made up there, and so there's only goodwill to be found.
Fraser, welcome to Chatter.
Glad to be here.
Artemis, the moon, we're going back, man. We're going back.
Maybe. Hopefully. I mean, you know.
Are you nervous about the launch pad?
Oh, like the launch pad being destroyed? Only slightly. Am I worried about it being delayed off the of course. Like, yeah. Rockets rarely launch, like a brand new rocket rarely launches the first time it is on the launch pad. And this is a brand new rocket that has a lot riding on it. And so every single check is going to be made. Every cloud in the sky is going to cause concern, and they will delay the launch at the drop of a hat. And they've got a bunch of launch windows queued up. And so I would not be surprised. We have a saying in the space journalism industry is that one does not book a return flight from a rocket launch because they, yeah. And I guess another quote that the rockets are like wizards, I guess. They launch when they intend to. And that a whole lot of Lord of the Rings references here. But I would not be surprised if they count down and then they delay and then they realize they want to push it back a couple of days and they do that. So within the next couple of weeks, I think we will see this rocket take off.
Fingers crossed, right? Now, this is not without controversy. Just the very launch system itself has a bit of dissension here. Talk through that a little bit. How is Artemis-I, whenever it does, how is it getting out of the Earth's atmosphere, and why has that been the topic of some controversy?
Well, which angle would you like? Because there's controversy
coming
hit all of
them
from multiple angles. So, yeah. Right. So, I mean, Artemis-I, this is NASA's return to the moon, and this was a goal that was announced a couple of years ago that they would return to the moon by 2024 and have human footprints back on the moon. And the stack of hardware that was going to be used to bring humans back to the moon was going to be the Space Launch System with the Orion capsule on top. And the Space Launch System is kind of like a reshuffled space shuttle. So with the space shuttle, you had the solid rocket boosters on the side. You had the big orange fuel tank filled with liquid hydrogen, liquid oxygen, and then you had the space shuttle orbiter that was bolted onto the side of this fuel tank. And as we saw with the tragic loss of 2 missions, it was never safe enough to really be relied upon for the kinds of missions that it was originally intended for. It was quite stuck with low Earth orbit, and because it had to lift the mass of the orbiter, it really couldn't go beyond low Earth orbit. And so even back in the early 2000s, plans were made to start to revise how the space shuttle was going to work into a system that was more similar to the original Saturn V and the Apollo mission. So you would have this very vertical-oriented rocket where it would use all of its thrust capability to launch its payload into not only low Earth orbit, but into orbits that would take it beyond. Mm-hmm. And so when if you sort of squint your eyes and you look at the new space launch system, it is a space shuttle that has been changed significantly. But still, the underlying DNA is there. And part of that is just that it allowed the existing workforce that was comfortable working with the hardware that was used on the space shuttle to transition over, or at least this was the plan, into the space launch system. The controversy just comes into the cost, that that at this point, it looks like, we're tens of billions of dollars in development for the Space Launch System. Each individual launch looks like it's going to probably come in around over $4 billion to launch. And when you compare that to other rocket launch systems on the market, say, nothing will compare to the Space Launch System. It is a ludicrously powerful rocket, but it's actually not as powerful as the Space Shuttle was. Space Launch System can deliver more payload, but the most similar rocket out there is maybe, say, the Falcon Heavy, which can't quite launch as much payload as the Space Launch System, but you could buy a Falcon Heavy launch for $90 million as opposed to $4.1 billion. Every part of the Space Launch System is bespoke and custom, and it is taking the beautiful RS-25 engines that were on the Space Shuttle, and it is going to be that were designed for reuse, and it's going to be dropping them into the ocean, destroying them. And so it's, the controversy of these beautiful engines going into the ocean. It makes me sad. So, yeah. But, if all goes well, it will be able to carry heavy payloads all the way out to lunar orbit. And Artemis-I will be an uncrewed flight, spend a lot of time out around the moon. Artemis-II will help prepare for the human landing on the moon, and Artemis-III will hopefully have human beings set foot on the moon again for the first time in essentially 50 years.
But we've got to learn some things from Artemis-I and presumably Artemis-II first. And I know on Artemis-I, they have set up these mannequins essentially to serve the role of Homo sapiens. And because they are not Homo sapiens, they have them more heavily censored and monitored than even a human being going up. So what was it? Something like more than 5,600 sensors.
Oh, that sounds right. I hadn't looked into that, but that sounds right. Yeah.
That's insane. They're measuring absolutely every millimeter that they can to figure out exactly what's going on. That's a huge advance over the Apollo missions and the kinds of monitoring they were doing in those early flights, right?
Well, just in general, 50 years down the road, everything has changed. And, when you look back at the Apollo missions, it was a $250 billion program to get humans to the moon. In inflation-adjusted dollars. So even though the Space Launch System is going to be costing, say, $4 billion to launch per rocket, the overall development cost is in the tens of billions. It's still almost an order of magnitude less than it cost to send humans to the moon the first time. Right. And the reason is because we have new materials, we have new technology, and we have computer miniaturization that can handle a lot of this stuff. And you can take all of this computer power and you can turn it into 5,000 sensors across a mannequin to detect every single vibration and rumble and use that information to more accurately predict how your rocket is going to perform on future launches. And that's really the goal with Artemis-I, with the first proper launch of the Space Launch System, with the use of the Orion capsule for over 30 days in the lunar environment. What does the rocket work? Like that's the big question.
That's the big
right?
number one, isn't it?
Right. Will it rocket? And if it does rocket, then will it rocket well? Mm-hmm. And then based on that, then we're going to find out how much radiation load will the astronauts be expecting? How well will the Orion capsule protect them while they're in lunar orbit, et cetera, et cetera, et cetera. And we're going to find out, hopefully, the answers to all of those questions. And then that will pave the way for the next Artemis mission to actually send humans and start building the infrastructure that's going to bring people back to the moon.
And for people who haven't been paying attention, and I assume when Artemis-I does launch, there will be massive attention to it and everyone will be familiar with it. But right now it's just starting to get into the general consciousness. But the Artemis-I mission, it's not planning on touching down. It's planning on going to the moon, spending a nice little vacation there, and then coming back. What's the plan for the capsule to return to Earth?
Well, I think of it like a fancy version of Apollo 8. So remember, Apollo 8 was this really cool, it's where they got those pictures of Earthrise, where you saw the Earth rising over the limb of the moon. And for the first time, human beings were able to see the far side of the moon. So in this case, what's different is that Orion is going to be sent. The Orion capsule is going to go out to the lunar environment and then perform a bunch of orbits around the moon. It's going to be in orbit around the moon for essentially a month. And it's going to be taking some orbits that carry it much farther away from the moon, even than they did in the Apollo missions. So it's going to be setting some new goals, although there won't be any people on board. If there were people on board, they would be the furthest away than humans have ever been from Earth. And so that's what's different is the Apollos never spent longer than a few days in the lunar environment. Mm-hmm. In this case, we're going to see a spacecraft designed to keep humans in the lunar environment for upwards of a month. Then it's going to take a return trajectory back to the Earth. It's going to re-enter the atmosphere, land in the ocean, get recovered, and they're going to study the data from all of those sensors on the mannequins.
Are you as surprised as I am? Go back to pre-adolescence Fraser, right? And no, this isn't getting creepy. I'm just saying we grew up at a time, I'm assuming like me, you grew up watching space missions, seeing the film of the moon landings and thinking we are in the space age. I mean, I remember reading books from the library as a kid about, life in the space age, and it was nonfiction, not fiction. And I guess if you would have asked me in the late 70s or early 80s, what do you think space missions will be like in 40 or 50 years time? I don't think I would have expected the answer to be, yeah, we're not going to the moon. We won't have anybody there again for about 50 years. We're just going to take a pause on it for a few decades. Now, putting aside a lot of other stuff we'll be talking about in terms of exploration of the solar system and other wonderful work related to space and astronomy, but just on the moon side, I would have disbelieved anyone who told me that we're just going to basically put the moon aside decade after decade. Does that surprise you a bit too, reflecting back on it?
Well, I think there's two parts to it. There's the what adolescent me thought about our role in space, but my brain was filled with Star Trek and Star Wars, and I had a deluded, overly optimistic, nonsensical idea of how difficult and expensive space exploration actually was. And then now, with the perspective that I have, and I look back at the rise of technology and the path that space exploration has taken, it feels inevitable that it took this pathway, that we got to where we are. There's nothing useful on the moon for humanity today, apart from a couple of bringing some rocks home to understand. The scientific interest of the moon is wonderful in the same way that the scientific interest of being in Antarctica. But it is a hostile place that's trying to kill you. Every moment that you spend there can only be done through an army of people back on Earth trying to keep you alive and bring you home safely. And it is incredibly expensive. And countries have priorities that they're trying to spend their money on. If we had continued on with the exploration of the moon, pushed on to asteroids, gone on to Mars, it would have made that expense just grow and grow and grow, while still delivering no tangible benefit in terms of anything beyond scientific research. I mean, there would be some incredible, when you think about the spin-off technologies that we get, better solar panel development, more compact battery systems, there are all these wonderful spin-off technologies that have this value back here on Earth. But purely landing people on the moon just delivers no benefit. Yeah. And so I think that what's different today, and I sort of mentioned this earlier, is that it's about the rise of technology that is constantly advancing. And when you map over the difficulty of sending people to space, of going to these far destinations, eventually those two lines cross, and suddenly it becomes relatively inexpensive. One eccentric billionaire can build a giant stainless steel tube and potentially overturn the launch market and build reusable rocketry. And that was just not possible 50 years ago. Like NASA couldn't have built a Falcon 9. And now a single private company with a few customers can build and sustain a reusable booster system and use that to build a 2-stage reusable rocket. So I think that things happen when they're ready. And what's happening today is because we're ready. We're not just hearing about NASA looking to go back to the moon. In fact, SpaceX is planning to do it privately. There's consortiums of other companies, I think like Lockheed Martin and Blue Origin were planning to send their mission to the moon. The Europeans are planning out a lunar village. You've got the Chinese that are absolutely on the way to sending humans to the moon. And there's probably 3 or 4 others that I haven't even thought of right now. And so when you see 10 different groups coming together on this goal, then you know that this is something that is now feasible and not destroy your country expensive. It's purely really expensive.
That's a really good point, that in the late 60s, early 70s, it was galactically expensive. It was a ridiculous investment, and spurred in large part by Cold War and security concerns and propaganda and image, as well as science and technology. The dynamics are different now. There's still all those things at play, and we'll talk more about those later. But it's definitely different in terms of the overall cost. The United States had to make a choice of, we are going to spend a boatload of money on this and de facto neglect some other programs as a result. And it's only now that, in a sense, we're reinvesting at that level, but it's not the same level. It's still a big investment. No. Don't get me wrong, but it's not the same massive. I mean, the idea of the moonshot was that it was such a huge thing to do, and so many hurdles to clear in technical terms and in financial terms in such a short period of time. We're blessed now, in a sense, that we're prosperous enough that we can afford this without necessarily slashing any other fundamental operations.
Yeah, I mean, it was purely to show to the Soviets that America could take the high ground. Yeah. That they had the better rocket technology, and the Soviets were to learn the lesson that everything the Americans do with space exploration had ramifications for their ability to drop ICBMs across the Soviet Union at the drop of a hat. That if you can send humans to the moon, you can nuke the Soviet Union to the Stone Age. So that it was the purpose, and it helped. On, the Soviets weren't able to keep up. Their attempt to land humans on the moon failed, and we saw further attempts to keep up with the technology lead to the breakup of the Soviet Union through the 1980s.
Well, you've been tracking this, issues related to the moon and issues related to space in general for more than 20 years professionally. I've only been listening to you on this topic for about 14 or 15 years. And that's because I was a very early listener to Astronomy Cast, the now, 650 plus episode podcast that you co-host with astronomer Pamela Gay. How did that come about? How did you choose to go into podcasting when it was still a relatively new format for communicators?
Well, I had a young child. I had a baby at the time, and she had trouble sleeping. And so I had to go on walks with her, and I'd take her in the stroller and I'd go on big, long walks. And I wanted to find educational content that I could listen to that kept me entertained. And there wasn't a lot. I mean, I was finding various episodes of some, in Canada, we have some great science radio programs that they've made their information available on the internet. I was able to download all that. I was able to find other stuff. And it was about that time when podcasting started to take off, and it was just a real natural fit. I much prefer to listen to audio content than almost any other way of gathering media. And I became a bit of a podcast addict, and there wasn't a lot out there, but I found it really fascinating. And I felt like, okay, I want to add, I've been running Universe Today at this point for maybe 5 or 6 years. And that was all in written word on the internet. And I wanted to branch out and add some of this audio material. So I started to interview people and record the interviews, because I'd have to interview these people anyway as part of a story that I was working on. I figured, well, after the fact, I was like, oh, people would have really loved to have heard me talk to that person and gather all of the pieces, and then I would turn that into a written story. But that conversation, that ephemeral conversation, was gone, and it was a really cool conversation to be part of. Why not bring people along for the ride? And then I was thinking about like a format to better understand astronomy and to better communicate it. And I reached out to Phil Plait, actually, the bad astronomer.
Sure.
I was like, I got an idea for a podcast. Do you want to do it? He's like, I'm too busy. But my friend, Dr. Pamela Gay, reached out to me, and she is an experienced podcaster, and she wanted to know if I wanted to do a podcast. And so he just put the two of us together, and we chatted. And I would say, like, one day we chatted, and then the next day we recorded the first episode of Astronomy Cast. And the format has largely unchanged from that moment, from when we started the show to today. I think the only difference is I know more, thanks to the education that I've gotten from Dr. Pamela Gay in astronomy and space. And in the beginning, I literally didn't know the answers to the questions that I was asking. Today, I am a lot more knowledgeable about what it is. And it's almost like I got my education from her, which has been great.
You're also, as you mentioned, the publisher of the Universe Today site, which is a wonderful source for astronomy and space news and analysis. In the last 15 years, things have really evolved, right? Because back then, as you said, you were asking questions. You were essentially making a career out of learning about this topic that you love. Now, you are the science communicator. You are the one educating people about these issues, and people come to you as a source of informed, but really easily accessible news. You go to Universe Today, which I encourage people to if they don't already, and you're not going to find a difficult scientific treatise. You're going to find everyday language communicating some complex topics. How have you evolved, and how do you consider that your scope has evolved as a result of that?
Well, part of it is I think I've figured out who I am and what I like and what I'm interested in. And I've really settled on what excites me about space and astronomy, and really kind of everything, but it sort of expresses itself in the work that we do on Universe Today, is that I'm really excited about what comes next. What are we right at the cusp of understanding? What new big discovery has been made? What new technology has been developed? What new missions have been proposed that can solve some of the big questions that we have, are a cool idea, cool way for us to overcome some obstacle and to push our understanding to the next level. And I seek out those kinds of stories, and then I sort of dump them into this big pile in front of the writers, and then the writers pick through them and find the ones that they're interested in and work on it. And I would say the voice of Universe Today really clarified in the last maybe even 5 years. Like, for the while there, we were just covering launch news, and people went on spacewalks, and this changed and that's new. And sometimes it would be news stories. And I really settled in on taking a firmer hand on the tiller as the publisher, and spending more of my time digging up the kinds of stories that I want to learn about, and then handing that off to the team. They're free to write about whatever they like, but they are also quite excited that there is this ready list of stories that they can pull from that are interesting and sort of fit the voice of the website. So I think that's where I'm the happiest. Is I want to hear about somebody who's come up with a really cool new way to overcome chromatic aberration in telescopes, or a way to have an air breathing ion engine to be able to remain aloft indefinitely in the atmosphere of a planet. Or I want to learn about a cool way to image an exoplanet through the magnetosphere as it interacts with its star. Like, these are all ideas. I'm looking for something that just makes me go, cool. That's really cool. And then I report on it, and I have zero interest. Like I don't think we've reported on a Starlink launch, none of that stuff interests me beyond the first time I heard about it. And then I'm like, I'm over it, and I'm
plus
moving on.
A lot of that is being covered by other outlets. It's almost
absolutely
as if it's something that hits the public consciousness in a way that that larger media organizations are covering. That's not your niche, right? That's not the value that you offer.
I mean, we have to cover a lot of these stories because it would be really weird if we didn't. Like if we just didn't talk about the Artemis launch, people would be like, how come you're not covering the Artemis launch? I'm like, wait, you can't turn in any direction and not bump into someone covering the Artemis launch. Are you not entertained? But so we kind of have to, but I'm definitely not interested in covering the stuff that has reached a lot of mainstream excitement, because it's just like, there's so much information out there. It's just a well-covered story. The stuff that I'm interested in is the stuff that nobody's heard of before. I really like finding some obscure paper from a researcher who has developed a really cool idea, and I know that we're the only people that are covering this story, and we're gonna do a good job of covering it on Universe Today. So I have to. I begrudgingly maintain stories on the stuff that everybody else is talking about, but I'm most excited about the stuff that nobody's talking about.
And one way that has reflected itself is in an issue you have covered a lot on Universe Today and Astronomy Cast in different ways, which are the coming efforts to put people on Mars. You've found different angles to put on that, different ways of examining that issue. So it's not all stories about, Elon Musk and is he going to get to Mars before the US or China, right? You're doing some interesting takes on it about the technology and about the risks of everything from cosmic radiation to microgravity effects on humans, not just on Mars because of the different gravity, but of humans who are in a zero gravity environment getting to Mars, and can they adjust even to the gravity of Mars itself? So I'm hoping you can talk through that a little bit. I think for the most part, the general public understands that getting to Mars and having any kind of sustainable human presence on Mars is really hard. I think people get that. I'm not sure people get just how hard it is, the order of magnitude of difficulty, but also all the ways that people are exploring how to do it anyway and how to overcome those hurdles. So for somebody whose knowledge of putting people on Mars stops at the book or the movie The Martian, take us forward a bit and explain some of those dynamics, both how hard it is, but how so many people in so many different ways, from material science to biology, are working on issues related to a Mars voyage.
I mean, to say it's hard is just a dramatic understatement. Mars is the worst. Mars is awful. It is, and it will never be good. It will always be a place where people go and suffer underground, eating biopaste, longing to see another dolphin. Mars is so awful, and I don't.
People of the future, please do not hire Fraser as your marketing convention visitors bureau representative. Yeah,
come to Mars, you'll hate it.
You'll suffer and then die.
He'll suffer and then die. This is how you died. Let's just roll through how bad Mars is first. Like, Mars has about a third the surface gravity of the Earth. So that sounds fun. It'd be fun briefly, but we don't know what the impact is of that kind of low gravity on the human body. Can babies gestate in the womb? Can they develop properly? We have no idea. There is, the temperatures are cold, that maybe in the equator, on the hottest day, the temperatures can rise to about 20 degrees Celsius, which is nice, but they can also go down to close to 200 degrees below zero on a cold night. And it can do it very quickly. You have those days when it's like a sunny day and it's really nice. And then suddenly the sun goes down and suddenly it's cold. Yeah. It just but ridiculous. There is no air. So that's a big one.
Well, when you put it that way.
There's just no air. The atmosphere of Mars is about 1% the density of the atmosphere of Earth. And so there's no way to go outside on Mars without having some kind of spacesuit. There is a constant radiation that's raining down on the planet. There's no global magnetosphere in the way that the Earth has. And so you take the full brunt of the radiation that's out there in space. And it is potentially 100 plus times more radiation load than you would be experiencing here on Earth. And the only way to protect yourself from this is to live underground, to get under about a meter of rock. Right. And that will block the radiation from that. There, the day length is kind of similar. That's cool. There's a lot less solar radiation falling on Mars than there is on Earth. It's about 1/4. So if you want to have the same amount of solar power, you need solar panels that are about 4 times as large as what you would have on Earth. So there's a lot going against Mars. And I always sort of say to people, like, if you want to know what it's like to be on Mars, go to Antarctica. That is a paradise compared to Mars. Go to one of those cold, dry deserts in Antarctica where there's no snow, there's no rain. It's bitterly cold. There's nothing to eat. It's boring.
Except you are relatively well protected against cosmic radiation.
You're protected against cosmic radiation. The gravity is fine, and you can breathe.
Yeah. So it's pretty darn easy. Yeah.
And so I think that is really important to hold in our minds when we think about, boy, wouldn't it be cool to colonize, to go and live on a city on Mars? It's people, for some reason, they think like it would be kind of like Las Vegas, but on Mars. But it's not. It's
well, it would be in the sense that you're taking a big gamble, right?
I can maybe. And so I think that, and so when people hear sort of my take on Mars, they're like, well, I was like, why do you even think people should go? Well, I think Mars is scientifically fascinating. I think it's really important for us to send human beings to Mars to explore Mars, in the same way that it's really important for us to send human beings to Antarctica, to explore Antarctica, to help understand the planet. It has all of these scientific questions that we want answered. The same thing with the moon. I want to look up at the moon and go, there's people up there right now. That's so cool. And that you're going to have a crew maybe of hundreds of people in a station on the moon with people coming and going, and they are performing experiments and they're studying what it's like to be on the lunar environment. It serves as a gateway to other places across the solar system, and the same thing with Mars. And I think that that when you go back to those lessons that we learned for the moon, why didn't people stay on the moon? Why didn't they keep going? Because there was no reason to do so. And we're going to reach that same point with Mars, where we're going to see the first footsteps on Mars, and then people are going to stop going.
Yeah.
And so you mentioned like all of the research that's being done, like what are people going to eat, and how are they going to go to the bathroom, and what's the low gravity going to do to their body, and how can they overcome this and all this? And I think part of this is the community that is quite excited about humanity's future on Mars, wrestling with the reality of what it's going to take. But we really won't learn those lessons until people try to go there and live. And that same work, I mean, how long have people been permanently inhabited down in Antarctica, just learning how to live in Antarctica? I mean, they're now starting to grow food in Antarctica in giant sea containers where they have LED lights where they're growing food. And it's going to be a similar situation where we're going to have to learn. And it's going to take us decades to learn every single downside and every single issue that needs to be overcome for us to live on places like the moon and Mars. And it may never be fun. It may never be just sort of like this cool, exciting, I'm living on Mars. I'm a Martian now, right? Move to Mars, get a job. So
do you think that, nothing like Total Recall, right?
Total Recall,
It doesn't look obvious to us.
Go to the colony on Mars,
do you think that we collectively have a false impression of people going to Mars, exploring like they did on the moon, coming back, and having as good a track record as we did with the moon? Because frankly, if you look back at all of the missions where we put people in space, got them to the moon and back, we did really damn well, like way better
Yeah.
than the technology and just the odds and statistics and random chance would have told you for things going wrong. Yes, some famous mistakes and some real problems. But in terms of people who actually made it to the moon coming back, does that give us a false sense of security that just because we're a few decades further on, that Mars will be the same and we won't have any catastrophic loss?
No, I mean, the moon is close. And so even if you have some emergency happen with a mission on the moon, they can come home and they can be rescued. Even if they have to send another mission up and it's going to take them 3 days to reach the moon, it is feasible. But once people head off to Mars and the flight there is 6 months and the flight back is 6 months, and you have to spend multiple months down on the surface and you have to wait for the orbits of the Earth and Mars to line up, they are on their own no matter what. And that's, I think, what The Martian, if you enjoyed The Martian, they really captured that idea that Mark Watney was on his own. And he had to come up with solutions to the problems that he faced by himself. And if he didn't, he would die. And we're going to look at something very similar to what happens with when humans do make that trip. And the way you solve that is through redundancy, through sending a lot of the resources in advance, in building spacecraft that are vastly more capable than are required, having lots of additional capability and resources along the way. It takes time and it takes infrastructure to make this journey safer and safer and safer as you go.
Yeah.
And people are going to always be balancing that. Do we make it safe or do we make it happen?
Yeah.
And I think that in the beginning, people are going to be erring on the side of both sides of that to try and reach that objective. People are going to die for sure.
Is it realistic? I think China has plans for a manned mission to Mars in about 10 years, roughly. And there are people, public and private, talking about the 2030s as a time for human beings on Mars. With all that we've talked about. Some people are saying
2026.
Yeah, to me, that's catastrophically ambitious. But what do I know?
Talking about exactly. Eccentric billionaires who want to send people in about 4 years or less. 2 years, maybe.
And that seems like a long time. For a mission like this, that ain't a long time. It's really hard to do all the steps to get there. Is the 2030s more realistic based on the trajectory you've seen?
Well, who knows? Part of me says that a bunch of astronauts, brave volunteers, could hop in a starship and arrive at Mars in about 6 months, land, tank up, enjoy Mars for a couple of months, and then make a rendezvous mission back and be back in time for Christmas. So that's one feasible possibility if you don't try to think of ways to make things redundant and safe and careful, and you just go for it. In theory, Starship can do that. It can launch, it can tank up in orbit, it can carry an astronaut crew, it can keep them alive with a lot of supplies for the journey to get to Mars. It can do repulsive landing down onto the surface. It can create its own fuel out of the Martian atmosphere, and it can return home and land them safely back at Boca Chica. So that is theoretically possible with the hardware that SpaceX is devising today. And I don't think we can rule it out. I'm totally ambivalent. I don't know if you can be totally ambivalent, but I am very ambivalent about their chances. And we are just a couple of months away from seeing whether or not this rocket will even begin this journey. If that method is off the table, then I envision we have studied many proposals of many different ideas that have tried to break up the journey to Mars into pieces that make a lot more sense. Like, what about going and building up a base on Phobos, which is one of the moons of Mars? Vastly easier to reach, vastly easier to escape from if you need to come home, if there's an emergency. You can build up a nice way station on Phobos. It's easy to get from Phobos down to the surface of Mars and back again. You can imagine building up this infrastructure piece by piece so that it becomes more and more feasible. And every iteration of this sees humans going to Mars. Like the safest version sees people going to Mars, as you said, in the 2030s, maybe arriving before 2040. And also, as you said, the Chinese, perhaps 10 years, probably more like 15 years. I mean, they're looking to have humans set foot on the moon probably by 2030, and then starting to set off for Mars. But they're gonna try and do a sample return mission from Mars in the early 2030s. So they're going to be testing every piece of their system, and I don't think they're going to have the same kinds of safety requirements and redundancy that other nations and people might. And so I think that we're looking at a vast range of what people are capable of doing and what they may be willing to do. Everything from seeing humans set off in just 4 years to it not happening until 2040.
You raise a fascinating point, Fraser, that, I immediately, from the national security background, I think about the China missions, whether it's the moon that we talked about or Mars, even space stations with the geopolitics of the ISS that we've seen recently, that I see it as geopolitical competition. Is the moon landings were part of the Cold War. And to the extent that China is a near-peer competitor to the United States geopolitically, then the space race to the moon and to Mars plays into that. But it's not just about geopolitical will and resources being spent. It's also about different attitudes towards things like astronaut safety. Is it important to have redundant systems for the redundant systems because it is such a freaking long time to get there and so much can go wrong? Or is it more important to be the one to say, yeah, we made it there first? There's a lot at play here. And you've tracked really closely a lot of the technology and a lot of the science that goes into it. But have you been tracking at all this competition internationally and how it plays out?
Well, I mean, no one will really just admit to it. No one's just going to say, this is a race. We're in a race. Sure. If we can get there first, then we're the best. Like, everyone gives a more reasonable, rational underpinning for why they're doing what they're doing. But obviously, like, China launches more rockets at this point than almost any other group in the world. They launch a ludicrous number of rockets, both for their own military satellites, their own communication satellites, as well as the human spaceflight they're doing, their scientific missions. They are absolutely taking over the launch market, but domestically, like for themselves. And for China to demonstrate that they have the ability to launch rockets, to send humans to space, to send humans to the moon, to send humans to Mars, that is a way to legitimize them as being as you say, a near peer. China doesn't want to be they want to be the best, right? They want to reach the top. They don't want to be a near peer. They want to be the top dog in technology, in economy, in everything. And they see it as a race. And being a spacefaring nation capable of sending humans to Mars and back is a way to demonstrate your capability, your superiority as a economic system, as a culture, and your technology. And I think that from their perspective, they are definitely in a race. And you can see that in the path that they're taking. It is a straight line to having humans set foot on the Mars and return. Every piece that they are doing is completely optimized to this objective. While when you see what's happening in Europe and in the United States, it is a wandering journey filled with conversations in the open market and contracts falling through and and different people responding to RFPs and so on and so forth. But for China, it is a series of check boxes that are being checked off one after the other, and the checks are getting more complicated, and the impact of those checks are more and more sophisticated. But at the end of the day, if you can set foot on Mars, it makes absolutely no difference to you as a nation. Like, you did it. You are able to send humans to space. Congratulations. It was incredibly expensive. Hopefully nobody died. It doesn't really materially change. It is a point of pride. And that is what we're going to see. And I think from China's perspective, they could say, hey, take us seriously. Look at what we did. Look what we can do. We can do this. We are not your manufacturing facility. We are your peer.
Yeah. It's interesting that the moon race was very much country versus country.
Even ideology, democracy versus communism.
You definitely had the Rocky IV feel to it all, right? But then with the International Space Station, at least in the public consciousness, there was this idea of, maybe we're moving to a new reference frame for this. Maybe we're moving to the place where space is an area that's best done through global cooperation. Given what's happened on the ISS since the Russian invasion of most recent Russian invasion of Ukraine, and given what looks like pretty strict geopolitical competition to get back to the moon and Mars, I mean, I worry about things like we saw in science fiction, which is you've got moon bases of different countries, which have to some degree become militarized, and you almost de facto have some kind of escalation of conflict into space when it need not be there.
I'm less worried about that. I mean, the Outer Space Treaty, and it is really an extension of the Antarctica Treaty. It very clearly defines what nations can and can't do with space, about weaponry in space, about the militarization of space. Now, obviously, someone can step away from the treaty and go, forget it.
Yeah, there you go. Yeah, we have to have some faith that it will be adhered to.
Well, but I mean, you interact with people on the ground. You interact with people here on Earth. So if you want to go and say, you know what, we're going to put our nuclear weapons in space, people can say, fine, but you no longer get to buy our oil. And it will devastate people's economy. So I think that we are still so interdependent here on planet Earth that any shenanigans in space will be dealt with fairly harshly, and nobody can afford to disconnect themselves from the global economy, or we are seeing the consequences of when someone does that, and it is not pretty. So I'm not really that worried. I think that it is, at this point, it's a point of pride, as I said, to demonstrate capability and to demonstrate technological superiority. But I think that we're going to see collaborations as well. And we're seeing a lot of great collaborations. China has one of the best radio telescope facilities in the world, especially now that the Arecibo telescope is no longer functional. They have the FAST Observatory, which is a 500-meter observatory. It's open to researchers from around the world. Scientific collaborations happen all the time with this incredible telescope. They're building the largest steerable radio telescope that's going to be used. They're building a whole series of space telescopes that are going to be almost certainly being used by international collaboration. They've brought on international collaborators with the space station, with their space station, the Tiangong, and so I think there's tons of opportunity to collaborate. At the same time, there's going to be lots of people attempting to one up one another, and it's going to be just like as it always was. And I agree. I mean, I think that when you look at the camaraderie of the Americans and the Russians on the International Space Station, it's really heartening. It's like that feels like that's what the future is. That's how you get the Federation in Star Trek, is people coming together, uniting as a planet to accomplish great things, to share the fruits of their labor, and for us to become very accustomed to seeing people from other nations as heroes too. When you hear about the cosmonauts who were out doing a spacewalk just a couple of days ago and because of a battery failure had to drop everything and rush inside, you were worried for their safety.
Right on.
And at the same and I don't think anyone has any ill will towards those cosmonauts, even though people may have ill will for the nation state that is currently invading its neighbor. Mm-hmm. So space can and should bring us together. And I think because there's no economic incentive to conquer space, I think that kind of collaboration will always be present and will be valued and will be part of this journey. If at some point we're seeing helium-3 mines on the moon and it's powering Earth's fusion reactors, then we've seen how resource wars play out, and I would have a different opinion. But for now, there's no money to be made up there, and so there's only goodwill to be found.
That's a good point, because a lot of the science fiction that tries to do a realistic portrayal of this, where you do have the entrepreneurs going into space, I don't care whether it's something farcical like Don't Look Up, or I guess the Alien franchise. Whenever you have somebody who's a rich individual and a corporation going into space, it's profit, right? It's Avatar, it's unobtainium, it's something that is going to make people on Earth presumably richer. That's not really what we're seeing now. The efforts we're seeing from wealthy individuals are doing it, maybe ego, maybe it's for the sake of doing it, but it's not, I'm going to invest $43 gajillion to get to Mars because I think there is a pool of raw diamonds there, right? That's not the motivation yet.
And you look at the history of humanity and you think about the kinds of overseas adventuring, and I use that in a very pejorative term, that people did. I was listening to a podcast. People were talking about just how when England started to really get its hooks into India back in the 1700s, and the boatloads of goods they plundered and the wars that they fought and started and the private armies that they were running, leading to 100+ years of colonization and imperialism. It's awful. But that's because people saw value and didn't have respect for the people who already lived there. And that is a story that goes back into the history of humanity for as long as we've had history. The Romans and the Carthaginians, when you look at these wars, the Mongols and their neighbors, like it just goes, and the Europeans finding their way to the New World. It just, the story is there was people already there. There was riches to be plundered. People didn't have any ethics about it, and horrors were unleashed. But space is not that. Space is rocks and sunlight and gases and ices. And from what we know, there's nobody out there in the solar system. We definitely want to be concerned about any other kind of life that could be under the ice on Mars or under the ice on Europa. And that's why I'm such a big advocate of the scientific exploration of these places first. But at the end of the day, an asteroid is just a mountain that's in space, and you're going to be mining it. And you're not going to be killing any trees, and you're not going to be pumping the waste into the rivers, and you're not going to be spoiling the atmosphere. Space can take almost any amount of pollution that we could dump into it. And so space, in theory, provides us a way out of the harm that we're doing to our planet today.
Mm-hmm. You mentioned a moment ago telescopes. And before the recent Artemis excitement, the big space news this year really has been the James Webb Space Telescope. I got to say that I was a bit surprised by the fact that one day I have on, I can't remember what was on the television, but I flip over past the cable news networks and CNN is going live to the NASA presentation of the images. They treated that as breaking news the way they would treat something like Russia invading Ukraine or a major political development. It was live and preempted their regular programming. And there have been some pretty impressive images. What has wowed you the most with the first several rounds of images coming back from the JWST?
It's interesting. I mean, I've been, as you said, for a lot of people, they switch channels like, oh, there's information about this technology. I've, of course, been following every turn of this telescope from inception through to its modern development over the course of 20 years. I've interviewed Nobel Prize winner John Mather, who developed the concept. I've talked to the engineers behind the scenes, and I've watched and reported on every trial and tribulation of this telescope. And so to see these pictures is relief. It is so wonderful to see. And what is so great is when you see the comparisons, when you're able to find these same regions of space seen in one wavelength, like seen in infrared, and then seeing it compared with the capability of Webb, and just how what were blurry blobs are now distinct stars and points. And we're too early. I mean, the pictures are great, obviously. And when you look at the pictures, you're seeing finer detail, but none of that really jumps out, because like there's a picture of Jupiter that's been just taken. But I mean, we've seen pictures of Jupiter from Galileo that are, and Juno that are orbiting the planet. And so you can't do better than orbiting the planet when you take a picture with the telescope. We're seeing pictures of the Carina Nebula. But I mean, we've seen pictures of nebulae with Hubble Space Telescope, and this kind of looks like the same. We've seen pictures of tons of galaxies, but we've seen the Hubble Deep Field. And so we're familiar with what it looks like to see a whole lot of galaxies in a picture. It's the underlying science that most excites me. And I think for a lot of people, they felt very underwhelmed seeing these pictures. They're like, that's it. Like, I was hoping to see aliens reading the newspaper on another planet, but that's not possible. But that you're looking at galaxies that would be completely invisible to the Hubble Space Telescope, because they're moving so fast and they have redshifted so far into the infrared. They would be invisible. You're peering through the cloak of gas and dust at the heart of a galaxy with a level of precision that you can see the environment around the supermassive black hole. You're seeing the readings of the atmosphere of a planet, and you're detecting the presence of water vapor in that with a level of certainty that was just never possible with any telescope before. It is about 4 times better than Hubble in terms of its capability to resolve things. So it's not 1,000 times better. It's just way better than Hubble. And so you're getting the suddenly questions that you had, things where you couldn't really squint and say, is that a bird or is that a dog? When you look through, you put on your binoculars, like, oh, it's a dog. Okay. Right. That's what you get. And so the papers have been just pouring out. Each week we're seeing the most distant galaxy. Like at this point now, I've stopped reporting on what is the most distant galaxy, because they keep finding it. And we're out of the relief first pictures phase, and we're into all of the scientists who have queued up time on James Webb are now getting that time. They're able to actually do their research. They're able to start to study and analyze. And then we have this delay, and we're going to be waiting 6 months to a year for them to report on what it is that they observed.
Sure.
So for me, what is exciting is that people can get to work.
Yeah.
And that's where we are right now, is all the people are now working hard studying these pictures and making their discoveries and coming up with the answers to the previous questions they had. And now they're generating the new questions, which will help us push science farther.
Let me propose something to you, and you can agree or shoot it down as a science and astronomy communicator yourself. I found NASA's initial rollout to frankly be a bit disappointing in one way. I feel like they missed an opportunity, given how much attention was on it, to really make the point you just made. And that is, when the first images and even the second round of images were coming out, they were everywhere. I mean, you could not escape them. You didn't have to go to Universe Today. You could turn on any news show, and that was on the broadcast. And the general commentary was, wow, these are impressive images. And I think most people saw that. Most people looked and said, that's really pretty, right? That's great. But what most outlets did not do, and I don't think NASA forced outlets to do, is to release the images side by side when you could, right? To show this is what Hubble Deep Field shows. This is what we're seeing of the same region now. Because that contrast is really the deep wow factor, the science factor, the development factor you mentioned, more so than just, oh yeah, that's another pretty picture. I've seen pretty pictures of space before, but this shows us things we've never seen before. And we're going to prove it by showing you a side-by-side image. Am I wrong about that?
Yeah, they had a few comparisons where you could see the older version, but it's a little trickier just because James Webb is in a wavelength that's different from Hubble, and so they don't overlap on what they observe. And so to really compare James Webb, you have to look at other older telescopes like Herschel or Spitzer, other infrared observatories, and we dug up a bunch of those. We're able to, a lot of people on Twitter did a great job of finding those original images and then providing the comparison so you could really see. But again, I think people were underwhelmed. Like here's the image and it's blurry, and here's the image and it is sharp. And they're like, so what? Right? But from a scientist's perspective, it's amazing. Yeah. You got 3 fuzzy data points that told you that the presence of water might be there. And then you got 90 data points that beautifully follow a graph that shows you an unambiguous signal that water vapor is in the atmosphere of that planet. One is a fuzzy hint that other astronomers are going to yell at you for not providing a lot of data. The other, it's just no one will argue with you what you drop on the table in front of them and go, this is water there, and everyone goes, agreed, and let's move on, right? So I think it's a tricky communications problem that I don't think there's a solution to it for the people who are interested in this kind of thing and they want to hear about the blow by blow accumulation of scientific knowledge. I'm here. Let's do it. I'm ready to bring it to you. And if that's not your bag, then don't worry about it. It's kind of like being into a sports team, I guess. And you're going to talk to somebody in the bar about every play that went on during a game. And someone could be listening to it and like, okay, so some people played hockey and someone won, right? Yes. Okay, great. Move on.
I want to find the bar you're talking about. Where can we get together with a bunch of people who want to talk at that level
James
over
Webb
drinks about astronomy?
That's communities. You find places where people are into the things that you're into. And I think it's perfectly fine for not everybody to be into space at the level of detail that I am, that maybe you are. But I'm also really grateful that everybody loves space. Nobody hates space. Hating space is like hating kittens. So there's a lot of fields where people are antagonistic towards each other about that thing. Yeah. Space is not one of them. Like, everybody loves space. And so I feel really grateful that I can be playing in a field that doesn't get that kind of anger and and volatility.
I hadn't thought about that because obviously working in the national security space, or even talking about issues of, good government and democratic institutions, you get hate mail, occasional death threats. Have you been the target of any trolling campaigns or hate
absolutely,
mail because of space opinions?
Of course. Yeah. I mean, I've gotten my share of death threats too. So, but it's
so much for the happy space community, Fraser.
Well, you take most people and you ask them what they think about space and they love it. There's going to absolutely be a hardcore conspiracy theorist group that doesn't believe that the moon landings happened, that the aliens are invading the planet, that the planet we live on a flat Earth, and most of it is religiously motivated and is looking to kind of push a larger worldview. And in general, those people are really mean, but I can just ban them.
Well, that's
this
interesting.
Is not for you. This is not for you. You're banned. Go join your flat Earth community and talk about your flat Earth stuff, but just don't do it near me.
Well, as opposed to a lot of other people in the kind of this wider community, in which I'll include things like, the Skeptic's Guide to the Universe and Shermer, and you've got a lot of people who engage on those issues to debunk the conspiracies of whether it's flat Earth or Stanley Kubrick, filmed the moon landing on a studio lot. You on Astronomy Cast and on Universe Today, you don't really engage with a lot of conspiracy theories. You don't do a lot of that debunking. Is that a conscious choice?
Oh yeah, absolutely. Yeah. It's not interesting. It's not productive for me. It's like for the folks at the Skeptic's Guide to the Universe, which is one of my favorites. I mean, they're really good friends and I really love the work that they do. There are other people who are doing debunking of the flat Earth stuff, and it is entertainment. It is a way to take a worldview, to dismantle it, hopefully to learn some lessons about how to perceive the world with a scientific perspective, but also to take a little bit of joy in another person's stupidity. And I am too excited and too interested and too busy talking about the concepts that excite me, that I am not interested in having those kinds of conversations. And so if someone wants, like, I'm not going to debunk flat Earth. Like, come on, that's ridiculous. I would much rather tell you about a really cool technique to extract the makings for solar panels out of lunar regolith so that you could build solar panels on the moon.
And you're not just making that up. That literally is a recent.
That is literally a thing that we have talked about. Yeah, absolutely. Yeah. Right. So these are, it's like, we just have to choose what we want to engage in. And if people want to if some random troll wants to show up and make you defend the fact that the Earth is a sphere, I get to decide how I want to spend my time. And that's not how I want to spend my time. Let's assume the Earth is a sphere. And then let's move on with the other really cool implications of that common assumption that we can hold together. And if you want to spout off about the moon, the Earth being flat, just leave. Just go. This is not for you. This is not the place for you. Yeah. And I have the same feeling about climate change deniers, about moon landing deniers, about UFO
alien visitations,
advocates, alien visitations. Like, it's just like I don't have any time for this.
Right.
And I'm too busy talking about the stuff that I do have time for. And my community has the same interests that I do. And we're going to be over here hanging out and chatting about space that we love. And you can be over there and talk about the things that you hate. And I'm not going to be a part of it.
I'll tell you, one thing you mentioned, I think, is slightly different than the others, or could be slightly different the way that it's done. And that is, and I won't call it alien visitation because that's too far, but the overall UFO phenomenon, because a change that I've seen since I was a kid reading every UFO book I could get my hands on to the last few years is not just the change in nomenclature to unidentified aerial phenomenon, but the fact that it is being studied openly as a national security issue to say, here are some things we've found, they're anomalies. We can't yet explain them, but we're not therefore saying it's aliens. We're saying we need to study these things more. And the Pentagon has actually been open about saying, we're actually exploring these things. They might be a national security threat. Obviously, we're not running around with our hair on fire that they are, but we're also not pretending that they're alien technology. We're merely saying that with the limited sensory input we have, we are not able to determine what caused this audio or more often visual effect. That seems a little bit different than flat earthers, right? There's some level of scientific scrutiny going into the former that is completely absent in the latter.
Well, the thing is, though, UAPs have nothing to do with space and astronomy.
It's a fair point. It's a perceptual. They have
absolutely
right?
nothing.
Yeah.
Like maybe it has something to do with atmospheres. Maybe it has something to do with airplanes. Maybe it has something to do with optics. Maybe it has something to do with but it has nothing to do with space astronomy, space exploration, any of the topics that I'm following.
Yeah.
And so, what is a UFO? It is unidentified.
Right.
It is flying, and it is an object,
or appears to be flying. Right.
Or appears to be flying. Yeah. Sure. And or UAP, right? Unidentified aerial phenomena. Same thing, right? It is unidentified. So we can agree on the U part, and you can't unidentify your way to identified. And so if someone says, here's this thing and I don't know what it is, but I think it's an alien, I'm like, well, didn't you just say that you didn't know what it was?
Yeah.
So if someone can show what the connection is between this and space,
right,
then if there's some evidence that I can look at that has anything to do with space, then it will enter into my domain and we'll talk about it. But yeah, I just haven't someone's like, yeah, but what do you think about this guy who had this evidence and he saw this thing? I'm like, can I see the spaceship? No. Can I take a ride? No. Can I shoot the ray gun? No. Well, then get back to me when I can. I would love for there to be evidence that extraterrestrials are visiting Earth and we could be interacting with it and we could be part of this galactic federation all along. I mean, it's all I talk about all the time is, are there aliens out there? How could we find them? Where should we look? What would it look like? What would be the impact? What kind of technology can we expect to see them using? What would be a glimmer of evidence that an alien technology was being used in a distant star system? I would say a quarter of the stories that we cover on Universe Today are just trying desperately to think of every possible way that we could search for evidence that we are not alone in the universe. I am the most excited person for the possibility that there are aliens out there. And yet I find none of this evidence compelling. And it's just, I'm not going to spin up the clock cycles to examine this. If there isn't hard evidence, then it just isn't that interesting to me yet.
It is fun that as a social construct, that if it's something unidentified, but it happens to be above a certain altitude,
right?
If it's under a certain altitude and it's an unidentified perceptual issue, it's fairies, right? Or at least 100 years ago, it was, photographs picking up weird effects, and they were fairies coming out of the woods to play with children. But if it's above a certain altitude, it immediately goes to, well, it's space and it's aliens. Sounds to me like, it could as well be attributed to magic or witchcraft. But once you hit a certain height, it must be aliens instead.
Yeah. I mean, have you talked to Mike West about this?
No.
I mean, he just gives you a perfectly plausible explanation for every single one of these things.
Right.
And you're like, I'm sold. Right. Yeah. Okay. Yeah. The math that you did on the angle of this and the camera tech that was used perfectly explains what that was.
Right on.
Or at least makes it feasible that was a bird, that was a Mylar balloon, that was a signal of a jet that was turning, et cetera, et cetera, et cetera. Each one of these things can be plausibly explained away with a fairly minimal level of investigation.
So it's fair to say that Universe Today will not be covering most of these topics unless and until there is some material found that is not of terrestrial origin, and then it's inherently interesting.
Bring it on. Yeah. As soon as it becomes a space story, we are on it.
Well, briefly, I want to talk just about some other issues related to space that you've covered now and again. I remember some probably 15 years ago when I first read what was then the new book by Neil deGrasse Tyson, Death by Black Hole, which was a fun read. And it got into, in part of it, the threats from space. Like, what are the things that could actually harm us? And of course, Phil Plait wrote the entertaining Death from the Skies, the science behind the end of the world. So whether it's gamma ray bursts, which frankly we can't do anything about if something happens near us, to near Earth objects, kind of close call asteroids, to, I mean, you name it. What are the, quote, threats from space that you see as the things that perhaps not individuals, but maybe governments should be thinking about the most?
Well, as you said, there are a bunch that are, in theory, existential to humanity and to life on Earth. Things like a nearby star becoming a gamma ray burst and stripping the atmosphere off the planet, a rogue black hole wandering through the solar system and destroying the orbits of all of the planets. Yeah, kicking the Earth into the sun, so on and so forth. But the chances of those kinds of things happening are incredibly remote. Even the asteroid strike, NASA has mapped out all of the really dangerous asteroids and has charted them forward into hundreds of years, and none of them are a potential threat to us. Like, at this point, they're looking for the ones that could wipe out a city. But the ones that could take out a continent are safe. The ones that could do what was done to the dinosaurs are non-existent. It's going to be fine. So when you think about the vast majority of the ways that space is trying to kill you, and make no mistake, space is trying to kill you, we're safe for now. The one that really does make me nervous is the sun. And the sun's ability to throw out coronal mass ejections and flares, which can interact with the Earth's magnetic field and cause disruptions to our satellites and to our electrical grid. There was this event back in the 1800s known as the Carrington event. This astronomer was looking at the sun and he noticed this really powerful flare. And then shortly after that, auroras were seen across the entire planet, right down to the equator. The telegraph lines caught on fire as electrons were jammed back and forth through the wires. And we got this glimpse of what's possible when a really powerful solar flare can hit the Earth. Now, our entire planet is connected by electrical grids. We have sensitive electronics flying overhead on airplanes. We have satellites. We have all of these things. And we know that it's just a matter of time before one of these really powerful solar flares hits the Earth, and we could see hundreds of billions, if not trillions of dollars of damage to entire electricity grids just getting bricked overnight.
Right.
And the consequences of everybody in the eastern seaboard not having power for a month.
Or
so what do you do?
Right? Because if the satellite network is disrupted, I mean, at least the Carrington event in the 1850s, sometime like that, at least then civilization was not reliant completely on technology for so many things. Now we're more vulnerable, and there's no real countermeasure to that vulnerability that's technically feasible on a moment's notice.
On a moment's notice, no, it's preparation. It is redundancy. It is breaking your grid into smaller pieces so that if one part goes down, it doesn't take the whole thing down. It's about having power systems. We're not great at that. No, I know. It's about having power systems that are online. It's about having hardened satellites, redundant satellites, so that if one goes down, another can take over the job and keep the communications flowing. So it requires a complete rethink about the way our electricity and communication system is put together. The good news is that would have all kinds of other benefits. I mean, we have all kinds of natural disasters, hurricanes. We've seen what's happened with all of the brownouts and blackouts in Texas with a fragile electricity grid in a state that has mountains of ways of getting energy. So I think that humanity needs to push towards better energy independence, better redundancy and a resilience to these kinds of events. And then you just set the Carrington event as your baseline and say, let's make sure that if a Carrington event happens, we will be able to get through it.
Mm-hmm.
That circuits are going to pop here and there, but the replacement parts are ready to go, and you switch over to backups, and you fix the gear, and you make our modern society resilient to that kind of an event. That is the only one that really kind of keeps me up at night. Mm-hmm. I think about the rising problem of space junk, but I'm not super worried about that. Mm-hmm. It's a bad day with the sun that makes me a little nervous.
I'm with you. Well, we end our conversations on Chatter by reaching into the Chatter box, which has a series of pre-printed questions, which I'll shuffle them up and ask you. Recommend any recent book you've read, podcast you've listened to, or TV show you've watched.
Well, so we're talking about the humanity's future in space, and the alternate view of that is, what if we did keep going? What if we did stay on the moon? What if we did push on to Mars? And there's this wonderful show on Apple TV called For All Mankind. Mm-hmm. And I think it's my favorite science fiction television show. And because it's playing so close to home, I was expected to be pissed off at the scientific inaccuracies at every turn, but I wasn't. It was both incredibly scientifically accurate, mm-hmm. but also took the kinds of ideas that had been proposed at the time and extrapolated them forward through several decades of a more ongoing presence on the moon and onto Mars.
That's
and
I
love the show. It's so good. Yeah. And the stories are great, and the people are great, and the characters are great, and the science is strong, and the depiction of the hardware and the kinds of technology that they do was terrific. So my recommendation is For All Mankind as a television show to watch.
I've heard you that's wonderful, and it's really against type, because I've heard you say before that when it comes to kind of the entertainment in the science and astronomy area, you tend towards the dystopian fiction.
True. Yeah.
To hear you praise something that is so not that is refreshing.
Yeah, there you go. Yeah. I am definitely against type on that one, but it's terrific. Yeah.
Final thought for you, Fraser. More on this line in terms of the fiction, the cultural influences on astronomy and space. It's such an interesting relationship over more than 100 years, the interaction of fiction and scientific exploration, one inspiring the other, whether it's Jules Verne, whether it's Star Trek, whether it's NASA spurring not only science, but also spurring a bunch of great writers, that there's so much to talk about. Maybe we'll have another conversation, but just curious, when you think about science fiction that doesn't necessarily represent every aspect of science right, but it gets enough right that it's plausible, and yet it's enormously entertaining and expands the mind. Maybe it's because I read it early. I always go back to Isaac Asimov's Foundation series, which I think is just as much about politics and galactic governance as it is about true science fiction.
I just reread them. Yeah.
They're not classically written. Isaac Asimov is not, winning prizes for his prose, but it makes you think. And that's the kind of science fiction I always liked growing up. What stands out to you in that area as the things that people really should be reading, even if they're not science fiction fans, but enough to open their mind a bit?
I don't really know. I mean, just like everybody loves space, I think everybody loves science fiction. That if you ask a random person on the street, do you like Star Wars? They'll say, yeah. I mean, do you like Star Trek? Sure. Do you like the top movies are science fiction? So I'm not that worried about that. I think that whatever you're into, there's probably going to be some level of science fiction. And I think the deeper part of that is why do you find that exciting? Why do you find that really interesting? There's something about us overcoming the unknown, about us reaching out beyond planet Earth to the stars, the mystery, the adventure. There's something deep in the human psyche that craves that kind of adventure. Yeah. And science fiction is one way that we can explore that. And I find like my job as a science communicator is to take these refugees from science fiction and show them what's really going on, what's really happening. Like, yeah, Star Trek was wonderful and exciting and you loved it, but it also filled your head with a bunch of nonsense about how easy it's going to be to get to other star systems, or what the future of spaceflight is going to look like. But the reality is just as exciting once you learn the details. And so I don't think it really matters. It's really what you're into. As you said, I kind of like my dystopia. There's so many great science fiction writers out there. You're going to find writers that match what you're interested in. And when you're ready to take the step to reality, but a reality that is as exciting and as thrilling and as adventurous as everything that you saw in science fiction, just in different ways, then we're ready. We got you. We'll give you the kinds of stories that you're going to find really interesting.
Well, Fraser, I appreciate you taking the time to chat with us today, and we'll be pointing people to your work at Universe Today and Astronomy Cast so they can read and hear more.
Wonderful.
That was Chatter, a production of Lawfare and Goat Rodeo. Please subscribe to the podcast and find us on Twitter at ThatWasChatter.